All right. Let's start up here. All right. So greetings, scholars. Let me see. No major announcements. Next week is going to be the last of the new materials. So today we're going to work on the homework, the corresponding homework for section 3.1. As usual, if you have questions or if you've emailed me and I haven't responded, just bring it up to me like sometime today before you leave, so we can make sure the matter is resolved and updated. Yeah, no, otherwise no real announcements. Let's just kind of get into the content. So I'm going to hop over to Pearson. Well, it seems fairly short. We might be able to finish. Okay. Let's see. Hey Siri, give me a random number between 1 and 20.
A random number between 1 and 20 is 20.
For some reason, I don't like it when she does. I feel like that's like the lazy way of choosing an endpoint. It kind of irks me. In 1627, an explorer convinced a group of indigenous people to sell him an island for $26. If the indigenous peoples had put the $26 in a bank account paying 5%, how much would the investment be worth in the year 2003 if the interest were compounded quarterly and continuously? Okay, let's write it out. And let's get a copy. Let me get a copy of all of this. I think I'm gonna try writing on grid paper today. Okay. So if we're doing compound interest, so we're going to use the compound interest formula. Let me see. That is A of t equals P times 1 plus R over N to the power of NT. Okay. So we are calculating the future amount. I know the principal. The starting amount was $26. Let's see the rate. Is 5%. As a decimal, that's going to be 0.05. Now we're going from 1626 to 2003. Hey Siri, what's 2003 minus 1626?
2003 minus 1,626 is 377.
Years? Let me see. And then part A, let me see, is we have what? Quarterly and continuously. Okay, so if we're going to do continuous in part B, that means we're going to use PERT, P e to the RT. Okay. And so then for A, our compounding, if it was quarterly, that means our N is 4. That means the interest is applied four times in a year. Okay. So then for part A, we're calculating the amount after 377 years. It's going to be the $26 times 1 plus the rate is 0.05 over N is 4 to the power of 4 times 377. I think I'm going to just use my calculator for that one. Okay, let's hop back over here. So we have 20. One plus is that. Then let's do nope. Plus 0.05 divided by nope. Heck on it. Let me try this again. 26. I'm gonna get it. I think that's K. 1 plus 0, no decimal, is colon. No, I know it's not that. It's not that. That's common. Cool. New. Okay, so I don't know. I think I'm just hitting the wrong button. Okay, last step. 26K 1 plus 0 point. There we go. 0.05 divided by is what? M divided by 4. Okay. Close parentheses. Hat. 4 times 377 multiply is R. There we go. 377. Cool beans. And close parentheses. There we go. We're getting the hang of this. Huh? That looks good. All right, we're getting this ridiculous number. Let me see if I can find it. Actually, it's going to be here. 3553. It looks like it's B. Come on. No. What? I want this to be full screen. Yeah, it's B. Let's go with B. Well, that was an adventure. Okay. So then for part A, what's the future amount if the interest is applied continuously? So again, we have to use the continuous compound interest formula, which is PERT. So then B is going to be A of 377. That's going to be 26 times e to the power of our rate, which is 0.05, and the time is 377 years. Okay. Time we got. Where'd it go? Here we go. Okay. So let's do 26. Now E, if I hit second S, there we go. 0.05 multiply. Nope, I missed a point. 0.05 multiply. No, multiplication is on. 377. Close parentheses. All right, that looks good. 26 times e to the power of 0.05 times 377. We get this 3994 number. $39.94. Full screen, come on. There we go. $39.94 looks like it's A. Let's go with A. Okay. As usual, if anything is not clear, feel free to unmute yourself to get my attention. I'll check attendance again in about 5 minutes at the 15-minute mark for any latecomers. Hey, Google, give me a random number between 1 and 20. Say that again.
Professor C, I have a question.
Here's a
yeah.
So when I put the formula into my calculator, it gave me a large exponential decimal. How do we simplify that to make it make sense in the context of the problem?
You did the exact same one?
Well, I'm on the same question. It's a similar format, but it's different numbers.
What kind of calculator are you using?
TI 84 plus.
you might have your float turned on. So if you go like mode, you see where the second button and to the right it says mode. I know yours is a little bit different. Um, just make sure everything is kind of set like this, like normal. Just leave it on float and try that and see if that fixes it.
Yeah, I have it on float.
Because your it's saying like 3 point something or whatever times 10 to some power, right?
Yeah.
If I mean another thing that you can do is just take that number and just move the decimal to the right by the power of 10.
Okay.
That's another thing that you can. I'm trying to think why it's showing like that. It might be something with the settings though. You might be able to change the setting so it doesn't do that. You sure you
Yeah.
have it set on normal? It's not on scientific or anything like that?
No,
Because I think
everything.
if I put mine on
Well,
scientific, go ahead. See, that's
mine
when
is
it does that.
mine is set in radians. That might be it. Should I change it to degree to see if that'll change it or not?
No, it's not that.
Okay.
Because mine is set to radian. I think it's really the scientific notation. Are you able to screenshot or take a picture of like your settings?
Yeah, I can.
We would have to like do a Google search. You have to like basically just dig into Google and like do a Google search for how to remove scientific notation on TI-84 plus or the one that you're working on and see
I'm
what
I'm
comes
just,
up.
I'm just gonna do that.
Okay. All right. I think the thing says 17, so we're just gonna go ahead and do 17. Okay. So sketch the graph of the function and check the graph. Because I don't have an 84 mod. The only one I got working is the one that I show. Sketch the graph of the function and check the graph of the graphing calculator before doing so. Describe how the graph of the function can be obtained from the graph of a base exponential function. Okay. So this question is really on transformations of graphs. If we're starting with the base function e to the x, notice there are two transformations going on, and they're both kind of directly affecting the x, right? So they're really inside our base function. It looks like the first thing we did was multiply the inside by a negative. So that's going to cause our graph to flip horizontally over the y-axis. And then we subtracted 5 on the inside, which should cause our graph to move to the right by 5. Okay, so it should be the graph of, let's turn this off. So his favorite thing to do is to pop up. Okay. So it looks like it should be e to the x. Shift the graph of this. Now the way that they're doing it, because like the way I described it is the way I would have done it, but the order is different. So I think that what we need to do is factor out the negative. So that way it'll be +5 first, which will cause it to move. I'm going to tell it to move left 5 units. Because the order in which you do this does affect the graph, but through repetition, you'll start to get the sense, right? So what I'm doing is rewriting the original. I'm going to factor out that negative. So I'm going to have e to the power of negative times the quantity x plus 5. So that way I can do the x plus 5 first. I might be messing it up though. Let me think. And then in either case, we are reflecting over the y-axis. It's just that if I were doing this myself, I would reflect it first. Let me think, because if we go, I would flip it and then go right 5. Okay, so another thing that we can do before we submit this, we can do a test point, a test value, right, to make sure that we have the proper graph. Let me see. Let me think about it. So when x is -5, for instance, yeah, we can plot those key points, right? So when x is -5, the corresponding y, we should have e to the power of 0, right? Which is 1. So when x is -5, the corresponding y should be 1. So move it left 5 units. So I think this actually should be right? And so basically what I'm doing, I'm putting what I think is the correct answer. I'm getting like visualizing. I mean, obviously I probably could and should draw it out. Let's actually do that. Let's get an image, right? But I was visualizing the image in my mind. I was like, okay, do we go right first or left first? And then if we flip it, the trick is coming, because if we flip it over the y-axis, what's going to be our position, right? Because if we subtract 5, that should go to the right? But because of that negative and how we're using it, it kind of throws things off. And we definitely are going to flip over the y. So then the question is, do we go left 5 first and then just flip it? But I don't think that's proper. If we go right 5 and then flip it, I think that puts us into the proper location, right? You kind of got to think about it and choose like a few test points, right? And so basically what I was trying to do was get to the exponent to be 0. And that'll give me a sense of where we should be, right? So then I realized that, okay, when x is -5, the exponent is going to be 0. So then we should be at the point -5, 1, right? And so that's only going to happen if we go right by 5 and then flip over the y-axis, all right? I just kind of thought about it. Because again, you saw initially I wanted to put left, but then I was like, well, let me check some points to make sure that that's accurate. Like go left 5 and then flip over the y, but then it doesn't work, right? So if I went left 5 and then flipped over the y, it's out of position. So then I was like, okay, well, let's try going right 5 first and then flipping over the y. And then I chose a few test points to make sure that it matches up, and it seems like it does. So I'm actually going to go with this result. I know that was a little bit circular, but I did that. I don't want to be like I did it on purpose, but I'm kind of glad that we did that. Because again, I did what I thought was right, and then I chose a few test points to check and make sure it matches the image, right? And then when I thought about it, it wasn't matching the image that we were creating. If we had gone left first and then flipped over the y, it wasn't matching. So then that's why I changed it from left to right. Okay. Hopefully that wasn't too terribly bad. And then graph. Okay. So we're going to use our exponential tool. I'm just clicking anywhere on the graph. We want to reflect over the y, and then we want to do a horizontal shift. I think we said left by 5. All right. So again, when x is -5, all right, the corresponding y is 1. That was the main one that kind of made me, that was the telltale sign that, what we had originally was wrong. All right. Okay. That was an interesting one. Let me check on you guys in Zoom. I'm pretty sure we had some people coming late. Let's go here. Let's see. So this one. Okay. So, yep, that looks good. Let him in. Okay, let's keep the party going. Let's see. Hey, Google, give me a random number between 1 and
16.
okay. I don't know if you all have ever seen this series on Netflix called The Good Place. It kind of chronicles this woman and her journey through like the afterlife. It opens up with her first day, in the afterlife, and so like one of the other protagonists, like the main stars in the show, is basically following 4 humans in the afterlife. It's a really interesting series or show. I'm bringing it up because one of the characters, his name is Chidi, and like it's so random. his like thing that he had to overcome was making a decision. And like whenever he had to choose, he got into like debilitating, paralyzing, like he got paralyzed by choices. Like he just could not make a choice. He's a brilliant, intelligent. He just couldn't make a choice. And like I totally resonate with the character. So because of that, that's why that's why I do the whole random thing with Google instead of just trying to choose something myself. I was like, okay, just do it for me, right? That's my way of choosing, you know. So, but I do that thinking about this character Chidi from the series. Find a principle that would generate this future value when where the future value is 11,000 at 8% compounded daily for 9 years. Okay. Okay, so we're doing compound interest. I mean, I guess I can write it here. No. I mean, I could. All right. Being a little bit lazy. I think it'll be okay though, all right? So we're doing compound interest, right? So let me start. I'm just going to take some notes here. So the future amount is going to be equal to P times 1 plus R over N to the power of NT. That's the formula that I'm using, okay? So now the future amount, I'm just going to leave it where it is. It's 11,000. It's on the far left. We're going to come back to that. Well, okay. Yeah, I mean, we can keep going. So here, 11,000 is really over here. Okay. So then on the right-hand side, now we're trying to solve for P, so I'm going to leave that. And then we're going to have what? 1 plus the rate is going to be 0.08 divided by the compounding. If it's compounded daily, it's going to be 365 to the power of, or N is 365 times 9 years, right? So essentially what we're going to have is 11,000 equals P times some number, right? Let me say that one more time. Essentially what we're going to have is 11,000 equals P times some number. So if we want to solve for P is going to be equal to 11,000 divided by whatever that number is, right? That's all it is. We're going to say the result is going to be 11,000 divided by whatever that number is, right? Okay. So let's find that number. Oh, I get an opportunity to type again, all right? 11, 1, 2, 3, parentheses, okay? So now we're going to have 1 plus 0.08, okay? Divided is M, okay? 0.08 divided by 365. Let's close off the parentheses. Is L. I keep being tempted to press the wrong thing, but that's okay. Then we want to take that. We're missing something. I'll come back and fix it in just a moment. So to the power is hat, parentheses, 365 times 9. So 365 replicated 9. Let's close up parentheses. Now I think we missed the division symbol. So I'm just going to go here. I want to insert, delete. Ooh, which one is delete? Let me see. This is a make or break. Did I get it? I don't think so. E, I know that's clear. It might be this. No, that's not it. Oh, okay. I'll figure it out later. Delete. I gotta find that one. Mode. It might be over here. And we want to insert a division symbol, which is M. Okay. Yeah, I think we're good now. 1 plus 0.08 divided by 365 to the power of 365 times 9. Okay, I think that looks okay. Then it says round to 2 decimal places. So it's 0.7, right? Because after the 9 is a 7, that tells us to round up. So then 69 becomes 70. So 5354.7. Now we just got to clear all this out. 5354.7. Can I just do all? 5354.7. Over here, I just want to figure out, let me see something. If I type delete, I just want to find what's delete. That's that. It's definitely not this. Oh, there's X, okay. I don't think it's that. Nope. What could be delete? It's not that, it's not that. That's clear. Insert. What else could I try? It's not that. It's not that. Okay. That's parentheses as well. Oh, you learn something new every day. What is this? No, comma. Oh, that's the only thing I'm missing. There's a minus, there's a plus. I know this is clear. That's not what I want. What else could I hit? Alpha, okay, that does something. There's a second. I don't know. I'd have to think. X. W? What did W do? I'm coming, guys. W is the minus. Here plus. Zero, okay. Learn something there. There's alpha. Now I'm just going for broke. What is this? Wait a minute, X, okay. D. It's up there, mode. There's X. Oh, that's not it. Oh no, come back. All right, I have to try that later to figure out what's the delete button. Oh, okay, I think I got it. Let me slide over. Let's go here. I got one thing I want to try. Okay, right here. No, I just knew that was gonna work. Backspace. How's backspace not? So let me clear. I'm coming, guys. These do anything? Nope. Okay. Yeah, I'm not sure. I can't find it. Maybe if I hit plus. Okay. I'll figure it out. I'll find it later. What the delete button is. Like I got everything else figured out, but I can't find delete. But that's fine. And then the y equals. Is that like F1 function? Nope. No. I don't know. Control? No. Shift? No. Function? It should be function. Yeah, I don't know. It's totally being temperamental. All right. I'm not going to worry about it. I'll figure it out later. Let me just read this. Oh, here, I'll do this. Okay, sorry about that. All right. So yeah, only thing I'm missing is delete. That would be great if I could figure out that. Good to know for that. Yep. Okay, sorry about that. We're back. Hey Google, give me a random number between 1 and 20.
Here's a random number. 5.
Graph the function on paper, then choose the correct graph. It's basically going to take on the form of a generic exponential function. A is the log function, B is a linear function, C is an exponential, and D looks like a power function, like an even power function. So I'm going to go with C. Hey, Google, give me a random number between 1 and 20.
Here's a random number. 14.
She is cooking today. Find the amount that results from a given investment continuously after a period of 2 years. Okay, so I'm going to take my notes here. If we're doing continuous compound interest, then the future amount is going to be equal to PERT, P times E to the power of RT. Okay, so we're trying to solve for A. So then our principal, we're starting with $20. Wow, 11%. I wish. Times E to the power of our rate 11 as a decimal is 0.11 times 2 years. Okay, so that's what we're going to put in our calculator. It's me and you again, my friend. Okay, only one that was a couple. I don't even know what those are either. A, B, C. All right. So we're going to say 20. Now E. So if I hit second S, 20 times E to the power of 0.11 duplicated times 2. Okay. And then it says round to the nearest cent. So 92 cents, $24. Oh, $4 for 2 years. Yeah, that's gross. 24.92. Yeah, 24.92. $24.92. Now, but if I had an account that had that kind of interest rate, that's definitely a valuable account. That's one piece of the puzzle, right? An interest rate like that, oh my goodness. And then the next, if you put $1 million in an interest-bearing account like that, oh man, you would have money forever, literally. As long as the account is open, right? Undisturbed, and you only touch the interest, don't touch the principal, you'll have money for generations. Ow! What? Hey, what? I'm in the middle of class. All right. Sorry, my Chihuahua wants to make a guest appearance. All right. So we're gonna check that. Okay. Hey Google, give me a random number between 1 and 20.
13.
If 9,000 is deposited to an account paying 3% compounded quarterly, what's going to be in the account after 8 years? How much interest? Okay, 8 years, right? So compound interest formula, A equals P times 1 plus R over N to the power of NT. That's the formula that we're using. So we're trying to solve for A. So we're starting with 9,000 times 1 plus the rate is 3%, so 0.03 out divided by it says compounded quarterly, so our N is 4 to the power of our N is 4 times our T is 8 years, and that's what's going in the calculator. Okay. So I'm gonna do my 9,000 parentheses, which is this one, cool beans. 1 plus 0.03, 0.03. Divide is M divided by 4. Close parentheses, hats, open parentheses, 4 times 8. We just say 4 replicate 8. Close parentheses, okay? 0.03 divided by 4, 4 times 8. Looks good. Okay, let's go with this. nearest cents. So you can do 11,431 now. 11,431. $2,431. Hey Google, give me a random number between 1 and 20.
15.
I like it with the last one because I have it on the screen. There we go. Oh. Let me zoom out. That's another way to get around this. There we go. Find the principal that would generate this future value compounded annually for 9 years. Okay, let me take my notes here. Get down. Wait. No, get down. We're about to go out. Give me like 5 minutes. All right. So let me take my notes here. No. Get down. A equals P. Let me see. Compounded annually. So P times 1 plus R over N. Come on, I can't type today. To the power of N times T. Okay. We're going to solve for P. So we want the future amount to be 10,000. And that's going to be equal to, we're solving for P, 1 plus the rate is 6%. So that's going to be 0.06 divided by, if it's compounded annually, that means our N is 1 to the power of 1 times 9. So it's just to the power of 9. So so P is going to be the 10,000 divided by that number. Okay. So we're going to say 10, 1, 2, 3. Divided by that number. So let's do an open parentheses. I guess you can just do 1.06. Close parentheses, hats, open parentheses. Oh, we didn't really need to open. Let's just do to the power of 9. Okay, I think that looks okay. Around the 2 decimal places, it's going to be 98. 59, 18, 98. 59, 18, 98. 59, 18, 98. Nearly $6,000. You gain 4,000 after 9 years. 6% is a good rate. Okay. All right, gentlemen, I think I'm going to stop there. Are there any burning questions before we go our separate ways? Going once, going twice. Okay, let me see. It's no real announcements. So again, we only have one more section of new content that we're going to work on next week. And then after that, we'll either be reviewing or we'll be on holiday break, okay? If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And we'll meet back next week, same time, same place. Take care. Peace. Come on. I know you got to go. We're about to go right now. She's eager to get outside. Stop. All right, gentlemen, take care.